Okay, the next part of the discussion in metallurgy is few important process in metallurgy. First one is smelting. Smelting is carried in blast furnace. Smelting is carried in blast furnace for extraction of iron. Then this blast furnace, if you take this blast furnace, it contains blast of hot air. This is zone of earth. This is blast of hot air. Here also blast of hot air. Otherwise this chamber is also called 2S chamber, 2S. And this is hopper. This is hopper cup cone arrangement. Cup cone arrangement, and here the temperature begins with 1200 degrees centigrade, then 1300 degrees centigrade, 700 degrees centigrade, and 300 degrees centigrade. So here we can see a small outlet, escape for waste gases, that is removal of slag and collection of molten metal. So here these are different zones. Here you can find here ZOH is called zone of earth. Where in this zone of earth molten metal is collected. Then zone of ZOC, zone of combustion. Here coke is a fuel. Coke is a reducing agent. So this coke is nothing but carbon solid plus oxygen gas. Half mole of oxygen gas gives rise to 1 mole of oxygen gas gives rise to carbon dioxide gas. This carbon dioxide gas in turn again reacts with carbon solid, which acts as a reducing agent to form carbon monoxide gas. And if you take a zone of reduction, ZOR, which we call it as zone of reduction, here when you take cup and cone arrangement, here you find all the mixture. This is called batch. This batch is made up of ore plus coke plus limestone. So here in the zone of reduction, ore is Fe2O3 solid plus carbon monoxide acting as reducing agent. It gives iron plus carbon dioxide, iron solid, molten iron, and it gives carbon dioxide as a byproduct. The molten iron which is obtained, it is in the still it has certain impurities, and this iron which is obtained, actually we call this as the cast iron, which is still has certain amount of impurities in it. That cast iron is converted to wrought iron in the next process. So this is the smelting process which is carried out exclusively for the extraction of iron. And if you take some more reactions like if you go for, that is zone of combustion, zone of fusion. If you take zone of combustion, next one is zone of fusion. If you take limestone, CaCO3 is limestone. If you heat this, you get calcium oxide solid plus carbon dioxide gas, and the impurity present in extraction of iron, impurity is silica. Silicon dioxide is the impurity, that is gangue particle. This is gangue particle. So take this gangue particle, that is SiO2. SiO2 is the gangue particle. It reacts with the calcium oxide, which is acting as flux. So flux reacts with gangue particles to give calcium silicate, which will act as slag. This is one of the important reaction which is taking place in the extraction of iron through the process of smelting, and smelting always requires the blast furnace. Smelting is a process which involves both roasting and calcination, and smelting always takes place at very high temperature. The smelting process definitely needs a furnace. That furnace is called as blast furnace, and blast furnace is exclusively used for the extraction of iron, and sometimes it is also used for the extraction of copper. Copper and iron extraction are usually carried out in the case of blast furnace, whereas the extraction of zinc does not require blast furnace, but it require an iron retort, and the purest form of zinc extraction in the metallurgical process, the purest form of zinc is actually called as, that is spelter zinc. And the purest form of iron, similarly in the extraction of iron, the purest form of iron is called wrought iron. It is pure because it contains only just 2% of carbon, and rest of the 98% of the metal is the iron. So if you go for the second metallurgical process, that is roasting. Roasting is heating the mineral ore. Ore is heated in the presence of oxygen below its melting point to give, that is the metal oxide and byproduct. So if you take for example pyrites, all pyrites mineral ores are subjected to roasting. Zinc sulfide, zinc pyrites, zinc pyrite, if you take it, if it is treated with the oxygen gas, it's a solid, it gives zinc oxide solid plus sulfur dioxide gas. So if you want to balance the equation, then I think if I take 2 over here, and if I take 2 over here, then if I take 2 over here, then I think the rest of the reaction automatically gets balanced. Take this zinc oxide solid, which we call it as zincite, and treat it with the carbon acting as reducing agent in an iron retort. The zinc oxide gets converted to molten zinc plus carbon monoxide gas. This zinc is called spelter, which we call it as the purest form of the zinc, which we call it as the spelter zinc. And this roasting process is always a pyrochemical process. It's a pyrochemical process. Smelting and roasting, both of them, they are pyrochemical process.